Everyone, welcome back to my channel Size Up. So today I will create another interesting video about indices as part of the systems design overview. So this will be a short video, but it's quite useful to understand how indices decrease write performance and some of the advantages of using such a tool. So indices are well known when it comes to databases. So sooner or later, there comes a time when database performance is no longer satisfactory. So one of the first things you should turn to when that happens is database indexing. So the goal of creating an index on a particular table in a database is to make it faster to search through the table and find the row or rows that we want. So you have all these tables and there's no way to locate the cells, and indexes help you do that essentially. So indexes can be created using one or more columns of a database table, providing the basis for both rapid random lookups and efficient access of ordered records. One example would be a library catalog. So a library catalog is a register that contains a list of books found in a library. The catalog is organized like a database table, generally with 4 columns. So you have the book title, the writer, the subject, and the date of publication. And there are usually 2 such catalogs, one sorted by the book title and one sorted by the writer name. That way, when you can either think of a writer you want to read and then look through their books or look up a specific book title you know that you want to read in the case you don't know the writer's name. So these catalogs work like indexes for the database for the books, and they provide a sorted list of data that is easily searchable by relevant information. So simply saying, an index is a data structure that can be perceived as a table of contents that points us to the location where actual data lives. So when we create an index on a column of a table, we store that column and a pointer to the whole row in the index. So let's assume a table containing a list of books. Here I will insert a clip of the index and mapping to the table. So just like a traditional relational data store, we can also apply this concept to larger data sets. So the trick with indexes is that we must carefully consider how users will access the data. So in the case of data sets that are many terabytes in size, we have very small payloads, for example, 1 kilobyte. Indexes are a necessity for optimizing the data access. So finding a small payload in such a large data set can be a real challenge. So since we can't possibly iterate over that much data in a reasonable time. So that's why it is very likely that such a large data set is spread over several physical devices, which means that we need some way to find the correct physical location of the desired data. So indexes are the best way to do that. So indexes do decrease write performance.